Welcome students, good evening everyone. We will today start with Module 9. In today's session we will be looking at steady state analysis. We will be solving some problems associated with steady state analysis. So let us begin our class. So in steady state analysis, basically we will be solving problems related to AC source. We'll wait for 2 minutes for some students to join as it is still 6. So we'll resume our class from 6 to 2 p.m. Okay, so in today's class we'll be looking at steady state analysis problems. So by steady state analysis we means that we'll solve the problems after a long time when the system has already crossed the transient period and is in a steady state. So these problems will be associated with a AC source. So a AC source will be a wave function of some amplitude and some frequency omega, which will be a function of time, and some phase phi. And the components associated will be a resistor, it can be a capacitor, or it can be a inductor. So basically we'll be solving network problems associated with these three components, that is a passive sources. So in case of a capacitor, we'll write the impedance XC as 1 upon j omega C. For resistor, the resistance is equal to the impedance, that is R. Doesn't depend on the frequency of the supply, whether it is a DC source or a AC source, the resistance remains R. And the inductance, so the inductive impedance XL will be given by j omega L. Also all the network theorems, that is the nodal analysis, superposition theorem, all these theorems will then we have Thevenin's theorem, Thevenin and Norton's theorem. Similarly we have mesh analysis. All these theorems will work same as we did for a DC source problem. So just the major change here is that we'll treat the impedance by this, and we have to write this Em in terms of a phasor. So we can write any wave function. So a standard equation is Em cos omega t plus phi can be converted into a phasor, that is Em the amplitude and phi will be the angle. And similarly if we have a sine, Am sine omega t plus phi, in that case the amplitude will remain same, but in case here there will be a minus 90 sign, because first you have to transform this sine into a cosine and then write it into a phasor. So these are the main basic summary for solving these problems. So without wasting any time, we'll move to the first problem. So in the given question, we have to use nodal analysis to find V0 in the circuit for the given figure, where the frequency is 2 kiloradians per second. So omega is given, and so our circuit has a dependent source here also, and we have to use nodal analysis to calculate V naught. So let us first of all mark the ground. So let us say that this is the ground potential, that is 0 volt, and we have to calculate V naught. So if you can see here at this node will be the same node as this point, that is V naught. This will be V naught. So we'll denote this as V naught. Also there are some other nodes. So this node, again these two nodes, this nodes, so I'll mark in red. So this node and this node are equipotential nodes. It is the potential at both the nodes will be same, and that will be equal to Vx. So let us mark only the single node this as Vx. Now we have to use nodal analysis to solve the problem. So first of all, let us write equations at the node V naught. So we'll take the direction of current away from the node. So in away from the node, the sum of all the current should be 0. So first of all, let us take the current that will pass through the capacitor. So the current will flow from high potential to low potential. Therefore, V naught minus Vx divided by the impedance by the capacitor. So we have to calculate Xc. Xc will be 1 upon J into omega. Omega is given 2 kilo radian, and the capacitor is 2 micro. So into 2, and there will be 10 to the power minus 3. So taking J above, minus J 10 to the power 3 by 4. So this will come out to be 250 minus 250 minus 250 J. Okay, so minus 250 J, this will be the Xc value. Similarly, the current through the dependent source is given in terms of Vx. So plus 0.1 Vx, direction is same, and finally the current to the resistor, that is V naught divided by 4 kilo ohm, that is 4000. So this is equal to 0. So we have an unknown term here, Vx. So for calculating Vx, we have to calculate from the other node. So we have to again write the nodal equation for Vx. So before doing that, let us first of all simplify this. So let us simplify the equation here. We can take V naught out. So V naught minus 1 upon 250 J and plus 1 by 4000 is equal to minus 0.1 Vx. So taking the LCM, 4000. So again we can send this rationalize the term, the first term here. So on rationalizing, we can multiply by J in both numerator and denominator. So the J part will get cancelled with the negative. So this will become plus J by 250. So taking the LCM part here, so this will be J multiplied by 16, it is 4000 by 250. 4000 by 250 comes out to be 16 and plus 1. So this times V naught, this times V naught is equal to minus 0.1 Vx. So let us first of all calculate Vx from the other node. So let us calculate that portion here. So again you have to write the nodal equation. So I'll rub this part. So let us call this as equation number 1. So this is our first equation. And from the other node Vx, we are to again write the equation. So again we'll take the current moving away from the node. So first of all, there is a current source of 36 sine omega t. So converting this into a phasor, this will be 36 minus 90 degree, since there is no phase angle phi is 0, so minus 90, and omega value is already given in the problem, that is 2000 radians per second. So the direction of current is opposite, therefore there will be minus sign, minus 36 angle minus 90 degree plus the current flowing away through the resistor, that will be Vx by 2000 ohms, and there is an inductor also here. So again we have to calculate the impedance of the inductor. So the impedance of inductor given by XL is equal to JL omega. So this will be J. L value is given 50 millihenry and omega is 2, so into 2. Here kilo and milli will cancel out. So this will be simply J 100 ohms. So let us replace that portion. So this will become Vx divided by J 100 ohms. Okay, and finally this part, that is plus Vx minus V naught divided by the impedance of the capacitor, that is minus 250 J. So no need to write the ohm sign here. So the sum should be equal to 0. So now from equation 1 we already have the value of Vx, so we can substitute the value of Vx. So I'll modify the equation, just multiply by minus 10 both sides, LHS and RHS. So minus will take this sign away and put a minus sign here, and multiplying with 10 will get only Vx here, and here will be multiplied by 10 factor. So this is Vx. So substituting Vx in above equation. So first of all, take Vx common, 1 upon 2000 plus 1 upon J 100 minus 1 upon 250 minus J 250. So this is Vx, and this is equal to V naught divided by minus 250 J plus 36 angle minus 90 degree. So now we have the value of Vx, we can substitute. So before substituting that, let us first of all simplify the terms in the square bracket. So it is 2000 inverse plus 100 J inverse minus 250 J inverse. So this comes out 150. So Vx times 150, angle is almost 90 degree, is equal to V naught by 250 J minus plus 36 angle minus 90 degree. Again we can simplify the Vx part here. So 10 times 16 J plus 1 divided by 4000 and multiplied by minus 1. This is, so Vx comes out 0.04 angle minus 93.5. So now we can simply substitute Vx. So Let us multiply this with 150 angle 90 degree. So this comes out 6 angle minus 3.5 is equal to minus V0 by 250 J plus 36 angle minus 90 degree. So again simplifying for V0. So let us first of all take that minus 36 in the LHS side. So this will become 6 angle minus 3.5 minus 36 angle is minus 90 degree multiplied by 250J, and there will be a negative sign also, so minus 1. So V0 I am getting as 90.31 angle minus 9.5. So this will be the voltage across the resistor. So let us move to next problem. So again in the given problem we have to use nodal analysis to find the current in this given circuit. Okay, so again in the given problem we are having 3 nodes. This node, so voltage at this node is already known. First of all let us ground the node, and the other nodes are this node and this node. So let us call this as V1 and this as V2. So again we have to write 2 equations separately for V1 and V2 to solve, and finally once we get V1 we can calculate I0. So let us solve the problem. So the problem will be solved in a similar way that we did in the question number 1. So this time again these 2 resistances are in. Okay, so one thing here you should always note is that the frequency of the supply. So here the frequency of supply is 2T and here is also 2T. So now we can easily use the nodal analysis. But if the frequency were different, we have to use superposition theorem. So first of all, let us write the impedances in terms of ohms. So these 2 impedances are in series connection. So first of all the impedance through capacitor is given by 1 upon j omega c. So this will be 1 by j. Omega is given 2 and c is given 0.25. So this will become 1 upon j 0.5. So we'll write this again in term of phasor. So it will be 0.5 iota and inverse. So 0.5 angle minus 90 degree. 0.5 I inverse. So this comes out two angle minus 90. Okay, and similarly I have to write for XL. So this will be j omega L, that is j times omega is 2 and L is given 2. So this is simply 4j. So 4j means 4 angle 90. So the sum will be XC plus XL since these 2 are in series. So 4 angle 90 plus 2 angle minus 90. So this is 2 angle 90. Okay. So we have now the impedance as 2 angle 90, the equivalent impedance. There is also a 1 Henry inductor. So for X 1 Henry inductor, 1 H Henry inductor, L is for inductor. So this will be J L omega, so J2J, J2 will be the inductance, so this will be 2 angle 90 degrees. This is 2 angle 90 degree. And similarly for the in capacitor XC, for the 0.5 farad capacitor, 1 upon J 2 into 0.5, so this is 1 by J, simply 1 angle minus 90. Okay, so we have now all the impedances here, 1 angle minus 90. So now we can start solving the problem by writing the nodal equations. So first of all, we'll write at node V1 the equations. So again, away from the node, we'll take as a positive sign. So V1 minus the current source, here you have to convert into a phasor, we forgot to do that. So 8 angle 30 minus 90, so 8 angle minus 60. 8 angle minus 60 is the phasor, 8 angle minus 60 degrees. Omega is 2, it is not required now since we have converted all the impedances. So V1 minus 8 angle minus 60 divided by the resistance, that is 2 ohms, plus V1 is connected to ground, so V1 minus 0 divided by 1 angle is minus 90, and V1 minus V2 divided by 2 angle 90. So these are the three components of the current that are flowing, is equal to 0. So again you have to separate the variables V1 and V2. So let us do that quickly. So V1 taking common, 1 by 2 plus 1 upon 1 angle minus 90 plus 1 by 2 angle 90, okay, is equal to the numerical portion here, 8 divided by 2 is 4, so 4 angle minus 60, and plus V2 divided by 2 angle 90. So this is our equation number 1. We need to have one more equation to solve, so let us write for the other node, that is at node 2. At node 2, that is V2. So the direction of current are here in these three fashions. So first of all, the phasor of cos 2t is 1 angle 0. So direction is opposite, so minus 1 angle 0 plus V2 minus V1 by twice angle 90, and plus V2 minus 8 angle minus 60 divided by 2 angle 90 is equal to 0. So again we have to separate the variables. So let us take common V2 as common. So 1 by twice angle 90 and plus 1 by twice angle 90. This is V2 is equal to 1 angle 0, this part, plus 8 angle minus 60 divided by 2 angle 90. The positive sign is there, and plus V1 divided by twice angle 90. So now we have to again add up these phasors, simplify the equation. So let us start. So first is twice angle 90 degrees, plus, okay, so this is simply 4 angle 90, sorry, 1 angle 90, so both the terms are same, so this is 1 angle 90, 1 upon 1 angle 90, that is V2 into 1 upon angle 90. So a minus sign you take in the numerator, so minus 90 will come, and we have to take the sum for this problem. So again 2 and 2 4 will be there, and 90 will take away, so again minus, so minus 150 will come. So 1 plus 4 angle minus 150. So this comes out 3.17, and angle is minus 140.9 plus V1 by twice angle 90. Okay, so we are interested in calculating V1, that is why we'll put substitute V2. So we have to further simplify V2. So I will write the value of V2 here. So V2 will be, we have to divide by 1 angle minus 90. So since this is 1, so therefore only angle will matter here. So 3.17 will remain same, 3.17, and we'll have to add plus 90. So angle will become 140.9 minus 90. So minus 50.1 plus again V1, the magnitude will be the same. In the denominator we have 2. So 90 and 90 will cancel out, so it will be by 2 only. So now we have the value of V2. So now we have to substitute V2 in equation number 1. So let us do that, substituting V2 in equation number 1. Substituting V2 in equation 1. Before doing that, let us simplify this portion here for V1. So again, so it is 0.5, 1 by 2 is 0.5 plus 1 divided by 1 angle minus 90. And plus 1 divided by 2 angle minus 90. This is 1.58, angle is 71.5. V1 is equal to 4 angle minus 60 plus V2. So for V2 you have to substitute V2 from here. So this, the first term is 3.17 angle minus 50 and divided by twice angle 90, and the second term is V1 by 4 angle 90. So again you have to simplify for V1. So V1 1.58 angle 71.5 minus 1 by 4 angle 90 is equal to the simplification of this term. So 4 angle minus 60 plus 3.17 angle minus 50 divided by twice angle 90. 5 5 angle is minus 80. Okay, so we can again rewriting this. So we have V1 is equal to 4.5 angle is minus 80 divided by the simplification of this part. So this part will come in the denominator. So let us simplify that quickly. 1.58 angle is 71.5 minus 4 angle 90 minus 1 upon 4 angle minus 90. This comes out 1.81 angle is 73.9. So let us call that 74. So simply V1 will be the division. So 4.5 angle minus 80 divided by 1.81 angle is 74. So V1 is 2.48 angle is minus 154. Minus 154 is the angle. So this is V1. So now once we have V1, we can calculate the current. So I naught will be V1 divided by 1 angle minus 90. 2.48 angle minus 104 divided by 1 angle minus 90. So 2.48 angle is minus 64. So this will be the current through the capacitor. So do solve this problem of your own and please tell me whether the calculations are correct or not. Since this is a lengthy problem, a small sign error can result into a big error. So you have to be very careful. So in the next circuit, determine Vx. So Vx is the voltage across the capacitor. Using any method of your choice. So here we are having two sources. So we can either use a nodal analysis or either use a superposition theorem. So since we have already solved two problems using nodal analysis, let us try to solve this problem using superposition theorem. So from superposition theorem, we can open circuit the current source and solve the problem, and short circuit the voltage source when we are taking the current source as the only source in the circuit. So let us first of all solve this with the voltage source. So once we have a voltage source, this will be a source, there is a capacitor, there is a resistor, there is, and finally this is a resistor and this is an inductor, and finally we have a, so this is, so all the three components here, these three components will become in series connection. So let us write this in series form, in the series equivalent. So 8 plus 10, 18 plus 6j, 18 plus 6j. It's 19. Okay. So to simplify the circuit further, we have a source connected to a capacitor, resistor, and a low supply, that is 18.97, angle is 18.43. This is the only voltage source, so we can solve this problem. So this portion and this 3 ohm will become in parallel, so let us do that also. So plus 3 inverse and the answer inverse, so it will be 2.6 angle 2.48, so it is called 2.5. So now we have reduced our circuit to this form. There is a capacitor and there is only just this form. So now we have to find the voltage across this combination. So we have to use the voltage division rule. So as per the voltage division rule, Vx1 is equal to, so the impedance of the load, that is 2.6 angle is 2.5 divided by the sum, that is the capacitor minus 2j plus 2.6 angle is 2.5 and the total voltage is 40 angle 30 degrees. So this will be the voltage from the voltage source at 3 ohm resistor. So let us simplify this again. 2.6 angle is 2.5 multiplied by 40, angle is 30, divided by the sum, that is minus twice I, plus 2.6 angle is 2.5. So this comes out 32.4 angle 68.5. So this is Vx1. Similarly, we have to calculate for Vx2, that is because of the current source. So in this case, we'll short circuit the voltage source. So short circuiting this will result in a circuit looking like this. So we have a current source here of 5 amperes. Okay. So we can first calculate the current here in this portion, and finally once we get the current, we can calculate the current further in these two branches. So let us calculate, call this as IT, total current IT. So the total current IT will be, these two are in parallel, so minus 2j parallel in 3 ohm, and then in series of 8 plus j6. So let us find this term here. So this term will be minus 2i plus 8 plus 6i. This is 10 angle 27.35, and there is a 10 ohm resistor. So the current through the IT, simply IT is equal to 10 divided by 10 plus 10 angle 27.35 times 5 ampere. So 10 divided by 10 plus this term multiplied by 5. 2.56 angle minus 13.70 amperes will be the current flowing IT. So now IT will again bifurcate. So IT3 through 3 ohm resistor will be minus J2 divided by 3 minus J2 times IT. That is 2.56 angle minus 13.70. So multiplied by minus 2i divided by 3 minus 2i. So this comes out 1.42 times angle minus 70. So Vx2 will be this multiplied by 3. So 4.27 angle is minus 70. So now we have Vx1 and Vx2. So simply adding Vx1 and Vx2, we can get the voltage. So Vx1 plus Vx2. Vx is equal to Vx1 plus Vx2, that is 32.4 angle 68.5 plus 4.27 angle minus 70. 32.4 angle 68.5. So this is 29.336 angle 62.96. You can write it as 63. So this will be the Vx. So we have seen two problems with node analysis and one with superposition. Let us move again. So now we have to use mesh analysis for fourth problem. So in this problem, there are 3 loops, and we have to calculate V0 and I0. So let us name the loops. Let us call this as 1, 2 and 3. And all the flows of direction, let us call this as positive 2. All are in clockwise fashion. So here we can say this as anti-clock as per the voltage source. So for loop 1, we have a current here. So for loop 1, the current is already given. So I1 is equal to 4 angle minus 30. Now let us get to loop 2. In loop 2, we have the direction of flow looks like this. So minus to plus, so there will be a minus V0. This is plus minus. positive to negative, so the positive sign I2 into 4j and minus to plus, so again a minus sign, 3 V0 is equal to 0. So I2j is equal to V0. 4 will get cancelled. So I2 is equal to V0 by j, or minus V0 j, that is 90 degrees. So now we have I2 in terms of V0. So we have to calculate again for V0. So it's better to have the notation in j terms only. So let us have I2 as V0 by j only. So I will clear this portion and write only I2. I2 is equal to V0 by j. Now for loop 3. So in loop 3, the source is from negative to positive, so minus 3 V0 plus I3 into minus 2j is equal to 0. Okay. Now let us find what is V0. So V0, here we are saying the direction of both I1 and I2 is opposite. I1 is in this fashion and I2 is opposite. So I1 minus I2 into 2 is V0. So let us substitute I1, 4 angle minus 30, minus plus V0 by angle minus 90. 1 by j, 1 by I is minus 90. 1 minus 90, okay. Times 2 is equal to V0. So V0 is taken as common, 1 minus 2 angle minus 90 is equal to 4 angle minus 30. So from here we'll get V0. 4 angle minus 30 divided by 1 minus 2 angle minus 90. .78 angle is minus 93.43. So V0, we have calculated V0. Now I0. So I0 is minus of I3. So here we have taken I3 as opposite of I0 in the 3. So I0 into 2j is equal to 3 into V0. V0 is 1.78. Angle is minus 93.43. So I0 will become 3 divided by 2i. So 2.68 angle 176.56. So this will be I naught. This is ampere and this is volt. So we have used mesh analysis to calculate I naught and V naught. So let us move to the next problem. In the given circuit, find I naught using superposition theorem. Okay, so both are voltage sources here. So first of all, let us consider the AC source. So with the AC source, this is 10 angle 0, frequency omega is 4 radian per second, and the circuit is connected here with a 4 ohm resistor, inductor and a 2 ohm, and this will be a short circuit. So 4 ohm, 2 ohm and 1 Henry. 1 Henry will become JL omega, that is J into 1, J into L is 1, omega is 4, so J4. So this will be J4. So let us calculate first of all the current through the inductor using the AC supply. So what will the total current drawn? So to the total current drawn, IT will be 10 divided by the equivalent resistance. So equivalent resistance is 4 plus 2 ohms in parallel with 4J. So this will be 2 ohms is in parallel with 4J. So 2 plus 4I inverse and plus 4 ohm, 10 divided by the answer. So this comes 1.76, angle is minus 8.13. This is the total current. So now we have to use the current division rule to calculate the current through the inductor. So I through the inductor, I1 will be 2 multiplied by the sum, that is 2 plus J4 times the total current, 1.76, angle is minus 8.13. So 2 divided by 2 plus 4I multiplied by 1.76, angle is minus 8.13. 0.787, angle minus 71.56 ampere. So this is I1. Similarly, I have to calculate I2 with the DC source. So I1 is here. This is I1. So now let us see with the DC supply. So with the DC supply, we have the inductor will be a short circuit, plus minus 8 volts, 2 ohm and 4 ohm. So no current will flow through this part of the circuit because this is a short circuit here. So the total current drawn by the inductor I2 will be simply 8 by 2, that is 4 amperes. This resistor will only take the part. So let us add I is equal to I1 plus I2. So is this equal to this comes out 4.31, angle is minus 9.96 amperes. So what we can say about the current? So the current here is lagging both the AC as well as the DC supply. It doesn't mean to say with the DC supply, but basically the current is lagging with the AC supply, because with the AC supply we have the phase given by 10 cos 4t plus 0. So phi is here 0 degree, and our inductor here is a negative, so therefore the current here is lagging the voltage by minus 9.96. And so if you have to calculate the lagging power factor of the circuit, that will be cosine of 9.96. Cos of 9.96 is around 0.98. So PF is 9.98 lagging. So that is all for today. We solved the network problems in steady state condition for the AC supply. So we seen the steady state problems with node analysis. So I will just go to the content section. So we have solved some problems with node analysis, with superposition, with mesh analysis, and in the previous modules we already solved the steady state problem using Thevenin and Norton theorem. Also we used this to calculate the maximum power transfer theorem. We calculated the value of load for which the maximum power transfer can take place. So with this I will end the module 9, and please join next week for module 10. So only 3 modules are now left, module 10, 11 and 12, for this course of network theorem. Okay, so thank you for joining.